with the organisms on Earth that were most likely responsible for the formation of all that oxygen on the banded iron structures very early on. So there's a definite link, and I've got pictures of stromatolites, particularly from Spirit Rover Sol 103, that show very clearly that these organisms did exist. One of the most important things about this that I want to get back to is we are in a race right now to get this information out there. The Chinese have a rover on the surface of Mars, and it's running around. They're going to find these things, and I don't think they're going to be quiet about it. When you're the only game in town, you can put a lid on certain information, but when other competitors show up, that's not necessarily true. And this puts NASA and other space agencies in a very curious position. NASA has insisted all along that nothing of biological nature has been found on Mars. Nothing that even barely resembles a fossil has been found on Mars. I'm going to show you that's not true. I'll show you a lot of material to you very shortly here. If the Chinese were to say, hey, we found what appear to be fossils, NASA's in a position where they either have to say, well, hold on there, that actually was already discovered back here at this time. And the moment they do that, that opens the door. You see, I've written a book that was published in 2008. I've done 40 or 50 radio shows just with Coast to Coast AM and a number of other radio shows, international shows, where I've talked about the findings. I published all this material online. And in fact, I sent it to NASA initially. And many of their scientists went to the site. The same links that I sent in the first initial email with the information were hit again and again from different sites, different universities all around. That email got around, and the signatures of their looking at those pages on my site was definite. It's in the logs for the web page, and so they know. They've known this since 2004. They don't want to say that there's life, and I have my suspicions about why, but it would have to do with how they're operating the rover in areas where there's liquid water. And we're contaminating the planet with terrestrial organisms right now. Bringing a sample back would be just as bad, because it's not that we would worry about a virus, because it's quite possible the genetic code of organisms on Mars would be different from our own. The virus wouldn't have any effect on us. But fungi or bacteria would be another matter. Bacteria will eat just about anything, mostly rocks, minerals, decaying matter. They break it down and make it available for other organisms. Plant life is a prime example of that. Soil is really a mixture of ground up rock, some organic material, and a live culture of bacteria. That's what keeps the soil functional. So the Chinese will have the American and European space agencies between a rock and a hard place very soon. And if they announce they've discovered what looks like fossils, then the fight will ensue. From my standpoint, I think that would be a positive thing, because it would prove my case all along. And what's most important here is that we get this information out to everybody, because it is factual information, and it's information we need. Stories about our universe, where it came from, what we believe, those are not so important. But the facts, the things that help us gauge how to deal with reality, those facts are the most important thing to get out there. And that's what I've been trying to do all this time. About the fossils. Now, I am going to say that there are other people who have written about potential of life on Mars. And one of the fellows is Dr. Barry DeGregorio, who was an astrobiologist, and he was kind enough to write the foreword for my book in 2008, A Fossil Hunter's Guide to Mars. Now, Barry had a theory about the formation of the spherules. It is a theory that was discredited at this point, but it wasn't a bad theory. And Barry knows a lot about Ordovician cavities and rocks, which is technical name for ancient rocks that had organic material that rotted away and left holes in. He's also very familiar with desert varnish, and he's found species that grow and inhabit an area in less than a century. And his findings are very interesting, because he can show that there really are living organisms on Mars now, but in his mind, it's mostly bacterial life, probably nothing much more complex than that. He is aware of the work that I've done. We don't necessarily agree, but that's okay. In science, you study things, you find facts, and at the end of it all, you dust off your hands some chalkboard dust, and you say, well, okay, this is right, this is wrong, and we move along. And I'm hoping that we will be at that point very shortly here. Um, One of the things I'd like to point out is people will say, well, the air on Mars has been exceedingly thin for a very long time and nothing could live in it. And you know, that's probably true, except for some simple life forms. But I would like to point out one interesting fact. An atmosphere doesn't have to be a gas, it can be a liquid. And our oceans are a perfect example of that. The organisms that live in the ocean breathe water. Gas exchange happens in the water. The water that existed on Mars was briny ocean water, sulfate salts in most cases, very likely, rather than chloride salts as we have. Over time, that probably shifts as the chemistry of the atmosphere and life itself changes the planet. Um, but what we see is that if you have very low pressure air, but water is in it, as long as gases can dissolve in the water, fish and plants can live in that water very, very easily. Much research was done at the Johnson Space Flight Center at 1/10 of an atmosphere, 1.4 pounds of pressure. And right now, today, we have 14.7 pounds of pressure, about 1,000 millibars. Um, what you're looking at with 1.4 pounds, 1.5 pounds is 100 millibars. As I mentioned earlier, the pressure on Mars, where they're doing most of their exploration, is around 7 millibars, which is very, very low, but it does not prevent the existence of liquid water. And there's another point. Scientists will say, well, you know, water would explode into a vapor instantly, it would boil away instantly on Mars, and that's absolutely untrue. It turns out the atmosphere of Mars is loaded with 10 times more water vapor than theory predicts it could carry. Now, what's very interesting about that is that there's a researcher by the name of Dr. Derek Sears who did some work and he found that water would have about the same rate of evaporation on Mars as it would on Earth because this is not distilled water, laboratory grade water under perfect conditions. This is dirty, salty water that has a different boiling point. And I'll give an example of how that can be. Many people go to the skating rinks, the ice skating rinks. How does that ice get frozen? The answer is those cooling coils down in the ice slab carry refrigerated brine, very salty brine that is much colder than the freezing point of water. Well, because it's carrying all that salt, it can remain a liquid at very low temperatures. The soil of Mars is loaded with salts where the oceans went away and left salt behind. Salt doesn't evaporate, water does. So what happens is when the oceans dried up, turned into glaciers, got rained away or whatever they did, they left all that salt behind in the soil. And any water appearing today will dissolve that salt and become a brine, which can survive to very low temperatures. That's just one of the examples of what's wrong with what they've been telling us. So we know that life can live in a surrogate ocean atmosphere. The ocean is a replacement atmosphere for organisms that would live on Mars, for example. One of the things I really think is the most important point of what I'm saying is that nothing sterilized Mars. Any life that existed on the planet before could quite possibly return if the conditions are only slightly more clement, a little more water, a little more air. But the bacteria is not a matter. It could be in the soil and functioning right now. And if Dr. Levin's experiments on Viking in 1976 are correct, then it is indeed. Bacteria can be dormant for ages by being dried out, and then a little water and food, and off they go. We've resolved that question long ago when we found that salt crystals, a quarter of a billion years old, 250 million years, could have bacteria inside them trapped, and when we dissolve the crystals, the bacteria would come out good as new and begin functioning. We've revived so many frozen or dried out organisms from historical materials, archaeological materials. That's not even funny. So you can bet that anything that lived in harsh conditions on a planet like Mars would be much more hardy than we would expect and could probably come back to life very easily. If we were to retrieve samples from Mars and bring them to Earth, we could be placing our planet in jeopardy. There's a great deal of danger with bringing back an organism for which we would have no resistance. We don't want to do this. Keep in mind that present-day rovers are collecting samples, storing them, and waiting for a vehicle to land and remove them and take them back to Earth. If this is to happen, then that's a big red flag. I would not try to send my children into a polio ward or into the bubonic plague. It would really be a foolish thing to do. Bringing an organism back like that could start out by living in the ocean and replacing our food chain from the top down, and it would mean that, oh, I'm sorry, from the bottom up are the basis of our food chain in the ocean and the basis of our atmospheric gas oxygen exchange happens in the ocean. All of our oxygen is not just from rainforest, only a fraction of it is. It's the shallow areas of our oceans that produce most of the world's oxygen. Poisoning the seas will remove our oxygen. And if these organisms are toxic and they start growing and organisms on Earth start eating them, they could die. And it would set off a chain reaction from the smallest to the largest, and it could wipe out life on Earth. We don't know. This is sheer speculation, but it is a very believable scenario and one that we need to guard against. I would highly recommend against bringing any samples back from Mars. Barry DiGregorio, that I mentioned earlier, is the founder of the International Committee Against Mars Sample Return, and it is for exactly these reasons. You can go to his site, icamsr.org, ICAMSR.org, see his material. Plenty of articles have been published showing supporting evidence for his cause, and join his cause. Let's stop any sample return missions. It would be foolish at this point. Now, I want to quickly go over some of the material. One of the things that I did is I discovered that I could find easy ways of calculating the proper balance of color in Mars images. Early on when I started looking at this material, and you'll see my backdrop right now is a picture of the edge of Endurance Crater. I'm basically sitting on Mars for this podcast. This image is in true color. One of my earliest jobs was at a print shop, and I worked in a dark room part of the time, doing color separations for halftone, full color prints. Used a densitometer and found out how it's done. And of course, being a scientist, I've studied a lot of physics and I understand how the optics works. So I could see that there was something terribly wrong with the orange sky pictures we saw. And I took the raw data frames and I analyzed the process. And I began putting together what the images should truly look like. And so this is an early image showing Sol 15. You can actually see the sundial on the rover with the color chips. And it shows you the true colors of Mars. You can see the red, green, blue, and yellow chips of the proper color. So using that information, I then derived a calibration curve and used it to assemble this picture. And you will see that the NASA logo is its proper color, red, white, and blue. And you can also see the dark color of the soil and the color of the spherules, which are really kind of a dark bluish gray. Those are mostly hematite. They thought they were concretions. They're actually fossil organisms. I can show you something about that in a moment. Now, taking that information, I went on to the Sol 15 picture of the rover arm and assembled it in true color. And you can see red, white, and blue, the American flag over there, just above the rock abrasion tool on the arm in the right of the frame. There's something else that's also very curious. You'll notice that the colors are very good, very clear. The soil is dark, it absorbs a lot of sunlight and heat. In the aluminum and stainless, which you can tell apart, you'll see the reflections of the sky. What color do you see? Do you see an orange sky? You do not. You see a plain white or gray sky. Very, very interesting, I would say. Now, just for reference, let's have a quick look at a couple of the instruments and the size of the rover.